This is from the 2004 HSC. Mike plays this game and he's got different potential wins or losses and different probabilities for each of them. Okay? Now what this is kind of like is what we looked at before with, say, rolling a die, and each of the options has a probability and each of the options has a value, 1 through 6 in the cases of a die. Here are the options for the values, and here are the options for the probabilities. So you might recall that we said there was this thing called expected value. We said there was equal to, and then I introduced this weird Greek letter. Do you remember I introduced the sigma? It's the Greek letter S, and it just means sum. Add up all of SUM, not sum as in some of them. It just means sum. So everything you're about to see over here, I want you to add up a whole bunch of things. What were the things we added up? There's two pieces in this.
The outcome times the value.
Okay, very. What's the P stand for? Probability of the outcome or event. Yep. And outcome and event, synonymous words. We're okay with that. But I think this is what I used. Very good. Okay. Now, financial expectation, all that means is, well, often the event that we're talking about is a financial event. You're going to win some money or you're going to lose some money or something like that. And you can see this question is exactly set up to help us evaluate this thing over here. Okay? So you're going to need your calculator in a second, but what we're going to put into that is, for here, Mike's financial expectation. It's going to be equal to, and I'm going to add up probability times value until I've done all of the possible events, until I've covered the entire sample space. What did I just do? Oh, did I? Yeah, I did order a taxi. Is it coming? Is it on its way? Is that what it said?
No.
Oh no, that's my wife asking. Is that? Oh, no. Got it. Let's turn off the internet. Okay, this is not so bad. In my year 10 class, I've got everything on, and then they Bluetooth, they airdrop things to me, and I'm like, guys, and it says like Space Sloth wants to send you a picture, and I'm like, okay, good. Anyhow, all right, I deserve that.
Can we do that?
Where was I? Well, you can't do it anymore. I just turned off my Wi-Fi. Okay, thank you. So I'm going to look at my three things, and I'm going to multiply each one across. But watch what happens. First, there's a 1/10 chance of winning $20. So that's your grand prize. So there's the probability of an event, value of an event. That's the first part. I might pop that in brackets. I'm going to have the next one. There's the probability of this event. This is quite likely. It's the most likely of all of the outcomes. 1/2 times $1. There's its value. Here comes the last one. The probability is 2/5. Now just watch out here. The value of this last thing is not $2. It's losing $2. So we have numbers for this. We would say these are negatives. So this is actually multiplied by negative $2. So the financial expectation bakes into it, yes, there is a chance that you'll lose out of this game, right? Okay, so you have a calculator there. Let me see if I can beat you there. That's $2. That's 50 cents. And this, 2/5 of $2 is 80 cents. 80 cents, right? So that's negative 80 cents. $2.50, take away 80 cents. That's going to be $1.70. Is that one of the options? Hooray, first one. Okay. So what does this mean? What does this mean? If, for example, Mike played this game 10 times, right? Sometimes he's going to win big, sometimes he's going to win little, sometimes he's going to lose. But each time, on average, he should expect to gain $1.70. So if he played 10 games, then by the end he might have, $17 or something around that. Does that make sense? So that's what he is expecting financially to get out of this game. So that's not too complicated an idea. It's just a money version of this, okay?